learn together, pass together, grow together. So, everybody gets this wrong. I'm just going to say it straight that 90% of people or world gets network speed wrong. That sounds dramatic, I know, but once you see the difference between bits and bytes, you will start noticing the mistake everywhere. Family members say it wrong, marketing pages blur it, even people in IT mixed it up when they are moving too fast. And when you are the one helping run the network at example shop, you can't afford to be fuzzy on this stuff, right? So our customer walk in, grab a product and connect it to Wi-Fi, and at some point, everybody going to ask how fast your internet. If I say we have got a 1 gigabit per second connection, that should actually mean something to me. Not just big number and sound fast. I want to know what they translate to be in the world. How long does it take to move a file across the wire? That's the real question. And here is the thing, this lesson is bigger than example shop Wi-Fi. Once you understand that, you can apply it everywhere. Your home internet, your office uplinks, file transfers, video editing networks, cloud uploads. Suddenly those speed numbers stop being marketing fluff and start becoming useful. Bits first, byte seconds. So before I can talk speed, I need to clean up one foundational thing. A bit is the smallest unit of data. Just a 0 or a 1. That's it. On or off. Computers love that because underneath all the fancy apps and glowing screens, they are really just dealing with electrical states and binary decisions. A byte is different. A byte is 8 bits grouped together, and that's where data starts becoming more human friendly. I usually think of a byte as a character like the letter A or the number 5. One visible piece of information, one thing I can recognize. That's why bytes are often how we talk about file size and storage. Hang on. If you ever seen the binary version of a number and thought, yeah, nope, you are normal. I don't sit around memorizing every binary value either. I think of it like a giant code book. Computers have ways of translating letters, numbers, symbols, and into patterns of zeros and ones so they can send that data across the wire. Once you have got bytes down, the next step is scale. We don't just talk about 1 byte because that would be absurd for modern data. So we group things up into kilobytes, megabytes, gigabytes, and terabytes. You have seen those terms all over hard drives, USB sticks, and file downloads. For this lesson, I want you to think of each jump as roughly 1000 times bigger than the last one. Yes, technically there is a 1024 conversion hiding in the background. I know, I hear the nerd alarms going off already. But for practical network speed calculation, thinking in thousands gets us where we need to go without derailing the whole lesson. So, that's the language of storage. Your hard drive is measured that way, your files are measured that way. That 2 hour video you exported for the project, that's probably measured in gigabytes. But network speed, uh, now we hit the place where people trip, the uppercase B problem. Networks measure speed in bits, not bytes. That means when I say our connection at example shop is 1 gigabit per second, I am talking about Gbps, where a lowercase b for bits. If I'm talking about file size like a 100 megabyte file, that uses an uppercase b for bytes. Tiny letter difference, massive meaning difference. This is where confusion explodes. Somebody says that they have 100 megabyte internet when what they usually mean is 100 megabit internet. And those are not the same thing, not even close. Since 1 byte equals to 8 bits, you have to divide by 8 when converting network speed in bits to transfer speed in bytes. That's the key. So now we can do something useful with the numbers. Let's say I have got a 100 MB file where MB is capital. Maybe some giant document, video clip, or report I need to move across the net. If my connection can move 125 MB every second, capital MB, then I just divide the file size by the transfer rate. Like 100 divided by 125 is equals to 0.8. That means the file takes about 0.8 seconds to transfer, less than a second, right? There is overhead. That's way more useful than just saying, the internet space is fast. Now I can actually estimate performance, and that changes how I think about infrastructure. And no, real life isn't always perfect. There is overhead, there is latency, there are protocol insufficiencies, wireless interference, and occasional chaos goblin living in your network closet. But the math still gives a very solid baseline. It helps me reason about what's possible before I ever plugged in hardware. In our example shop, a 1 gigabit connection is probably plenty. We have got customers streaming a little video, checking emails, scrolling social media, maybe a point of sale system talking to cloud services. Nothing too insane. Espresso machine. But as network grow, this math become a superpower. If I am designing a network for video editing, backups, server replication, or huge cloud transfers, I need to know whether 1 gig, 2.5 gig, 10 gig, or faster links make sense. Otherwise, I'm just guessing, and guessing with infrastructure get expensive fast. So the big takeaway is this: storage is usually measured in bytes and network speed is usually measured in bits. And the bridge between them is 8. Once that clicks, you can estimate transfer times, size links properly, and sound like the person in a room who actually know what the number means, which by the way is bit cool.